Hi, I'm Pavan from Kausalya classes. Today I'm going to teach you complex number. Before dealing this topic, you should just recall the previous topics which you have already learned in your previous classes. So let's discuss few points. Let us suppose I'm having an equation x plus a is equal to b. If a and b belongs to natural number, then it will be difficult for you to solve this equation for natural number because if I'm gonna make a condition that a is greater than b, so you will not get a single natural number who is going to satisfy this equation. Because for example, let us suppose you put x plus 9 is equal to 2, you will not get a single natural number who is going to satisfy this equation. So now at this stage you have to extend natural number to integers, in which every equation is in the form of ax is equal to b, where a and b belongs to natural number. It's soluble, but the equation of the form xa is equal to b, where a and b belongs to integer and a is not equal to 0, are not soluble in integer also. Therefore, set of integer is extended up to rational number because the value will change. Okay, so now the equation of the form ax is equal to b, where a is not equal to 0 and ab belongs to integer, is uniquely solved if you are going to extend your number system up to rational number. But what about the equation x square is equal to 2? You will not even get a rational number whose square will give the value 2. You will not get a single rational number whose square is gonna give you 3, right? So you have to extend your number from rational number to irrational number. Once you will extend that, you will get the unique solution of this expression. But in this contest, I have another equation also. What will happen if I'm gonna write x square plus 1 is equal to 0? If this will be the expression, what will be the solution? If you will even try to solve this equation, this will give you minus. And let us suppose this x belongs to real number. So you will not get a single real number whose square will give you the minus 1. So now at this stage you have to extend your idea from real number to complex number. And one scientist, he was not scientist, but you can say his name was Euler, who was the first mathematician to introduce the symbol iota. And he said, if I'm trying to solve this kind of equation, I will get this expression, and x will be nothing but under root minus 1. And he said the value of under root minus 1 will be iota. So iota is equal to under root minus 1. So if I'm gonna square iota, so both sides will get squared and value will be minus 1. If I'm going to cube the iota, if I'm going to find out the cube of iota, I can write iota to the power 2 into iota to the power 1. And I know iota to the power 2 from the previous idea that this is minus 1. So minus 1 into iota will give you minus iota. If I'm gonna raise the power further, iota to the power 4, this can be written as iota to the power 2 and iota to the power 2. So iota to the power 2 will give the value minus 1 and minus 1 This minus 1 and minus 1 will give you the value 1. So I have listed something. What I told you, I told if you have an equation x square plus 1 is equal to 0, the value of x will be under root minus 1, which is not possible in case of real number. So Euler said that the iota is a Greek word basically. Iota is equal to, or he symbolized this expression with a Greek word that was iota. So when we squared iota, we got minus 1. The cube of iota was minus iota. Fourth power of iota is 4, and the value will be 1. So what happens if I'm going to increase the order of the iota further? For example, let's iota to the power n. N for n is greater than 4, because we know iota to the power 0 will be 1 itself. So we know iota to the power 0 is 1, iota to the power 1 is iota itself, iota to the power 1 will be iota itself, iota to the power 2 is minus 1, iota to the power 3 is minus iota, and iota to the power 4 is 1. So what if the value, or if the order of iota is more than 4? So if n is greater than 4, we divide n by 4 and obtain the remainder r, and quotient m. So by the logic of division, we can write this expression n is equal to 4 times m plus r, because this m is quotient, this r is remainder, and this n was divided with 4. So instead of writing iota to the power n, we can write iota to the power 4m plus r. So we know that if I have divided natural number n with 4, the remainder will be only 0, either 0 or 1 or 2 or 3, right? So this expression can further explained in this way: iota to the power 4m into iota to the power r. So iota to the power m can be written as iota to the power 4 to the power m, and we know that iota to the power 4 is 1. So power of 1 will give the answer 1 itself. So the answer will be iota to the power r only. If you have a value n, means iota to the power n will give you the answer iota to the power r if we have divided this n with 4 and remainder is r. So this idea is going to help you to find out some of the complex parts or orders of iota. For example, if you are trying to solve the equation or the expression iota to the power 99, so you have to divide this 99 by 4. What you will get? 2, 8, 1, 9, 4, 16, 3. Okay, so instead of 99, you can write iota to the power 24. Iota to the power 4 into 24 into iota to the power 3. When you will solve, you will get 99 only, because 4 into 24 will be what? 96, right? So 96 and 3. I used indices. We know that a to the power m into a to the power n is equal to a to the power m plus n. We applied this logic to solve this problem. Now, we already know that this expression is gonna be 1, because instead of this expression, you can write iota to the power 20, iota to the power 4 to the whole power 24, and once it will become 1, this will give you the value 1, and 1 to the power 24 will give you 1 itself. So 1 into iota to the power 3, and we know that iota to the power 3 is minus iota. So the answer of iota to the power 99 will give you the answer minus iota, and minus iota is nothing but minus iota is nothing but minus under root minus 1. So you can solve any problem. If someone is gonna ask you another question like iota to the power minus 99, so you can change this expression in this way. I just took the reciprocal of this expression so that the order will become positive 999. I can solve further, and we discussed that if I'm going to divide this 999 with 4, the answer will be 28194 16399 36. Answer will be 3, remainder will be 3. So instead of this I can write iota to the power 4 into 249 into iota to the power 3, and this will become 1. So the answer will be iota to the power minus 99 is equal to 1 upon iota to the power 3, and we know that iota to the power 3 will give you minus iota. And if I'm gonna rationalize it with minus iota and minus iota, so this will give you the answer minus iota upon minus minus will become plus, and iota will give you iota square, and iota square will be the answer of iota square will be minus 1, as we have already discussed. So minus iota upon minus 1, this minus minus will get cancelled, answer will be iota. So answer, or if someone is going to ask you that evaluate this value, the answer will be iota itself. So this is a very simple concept you can understand. If you have any doubt, you can just go back and see this video once again. It will be easy for you to understand. Even you can solve this this kind of problem, complex problem also. If someone is going to ask you that, okay, find out the value of iota to the power 19 plus 1 upon iota to the power 25 to the whole power 2. So it's very easy. You should go with the step by step. What you can do with this, you should divide this 19 by 4, you will get the remainder 3. So instead of this you can write iota to the power 3 plus what will be the answer for this expression? Okay, 1 to the power 25 will give you 1 itself, and iota to the power 25, if you're gonna divide this by 4, you will get the value iota to the power 1. So iota to the power 1 is iota itself, right? So it's very easy to solve. See here, iota to the power 3 will give you minus iota. So minus iota plus 1 upon iota. I'm gonna multiply iota in numerator and denominator. So this expression will give you minus iota plus iota upon iota square, and iota square will give you the value minus 1. So when you will solve this further, minus iota minus iota, because this will give you the value minus 1, so this plus will become minus, so minus iota and minus iota will become minus 2 iota. Okay, so minus 2 iota, you got it, you got the value minus 2 iota. So if you are going to put the value over this, you will get 2 iota to the power 2. So you can further solve this expression, minus 2 to the power 2 into iota to the power 2. You know minus 2 to the power 2 will become 4, and iota square will give you the value minus 1. So answer will be minus 4. So if you will have this kind of problem, you can solve this kind of problem step by step, and you will get the answer, and the answer will be the correct answer. Thank you so much. In next part we are going to discuss the imaginary quantities, or how we are going to give the expression of complex number, and what was the next subtopic of complex number we will deal in next lecture.